As industries increasingly adopt artificial intelligence technologies, using AI-powered predictive maintenance is helping companies optimize performance, reduce downtime, and extend the lifespan of machinery. Ultra-low RPM machines, however, have a unique set of challenges given their slower operating speeds. Joining us today is Artem Krupanev, Vice President of Strategy at Augury, to help us understand the technology behind this latest machine health tool. Thank you for being here today, Artem.
Oh, it's a pleasure. Thank you so much for having me.
You bet. So before we dive into the questions, I was wondering if you could give me a little bit of background on Augury and your role there.
Absolutely. So Augury is one of the first industrial AI unicorns. We're valued at over $1 billion in this industrial space, and we're a leader in a number of categories for that really serve the industrial world and primarily process manufacturers. So we have two main solutions. One is called Machine Health, which essentially is leading the predictive maintenance space for manufacturing. Another one's called Process Health, which is also leading. It's an earlier stage product, but it's already leading the process optimization space for the same types of manufacturing. And we work across multiple segments of the industry, from food and beverage to chemicals and petrochemicals to plastics to building materials, things like cement, wood products, pulp and paper, pharmaceuticals, and many other segments across the industry, kind of covering the full life cycle of products. We say, everywhere from pharmaceuticals to diapers to beer, for instance.
Mhm.
So, and we really power those manufacturing lines in terms of their availability, reliability, and the yield, the quality, and the throughput of those production processes without changing fundamentally the actual machines and actual processes that are being run, but adding AI-driven solutions on top, including hardware, to be able to diagnose those processes and machines and to be able to provide accurate prescriptive recommendations on how to improve them, and putting that into the hands of the operators, the technicians, the maintenance leaders, the reliability leaders across those factories.
Fundamentally, can you tell me why are ultra low RPM machines so difficult to monitor continuously, precluding them from being maintained predictively until now?
So I think it's not just the difficulty of monitoring them continuously. If we look at Augury's capabilities today, we're a market leader in AI-driven prescriptive maintenance with machine health, which means that there are hundreds of machine types and components that we monitor today, and we have highly, highly accurate AI algorithms that actually detect issues and tell technicians fully prescriptively exactly what to fix, when to fix, how to fix, weeks and months in advance with over 99.9% accuracy. And we actually guarantee that accuracy. And that covers the majority of different types of rotating equipment. And the majority of that equipment within almost any industry rotates rather quickly. The difficulty comes when we start looking at really slow rotating equipment. And the reason for that is, this is not just for Augury, this is just in general. Historically, that type of equipment has to have a very high frequency signal and very long sample times. So what I mean by sampling, how long of a sample do you take from a sensor on a slow rotating bearing? It could be as much as a few minutes of a sample. And you also need a very high frequency in terms of the resolution of that sample, because the actual friction, or let's say the noise that's generated within that rotation, is very, very subtle, right? So you need a high frequency sample, just physics, in order to be able to get a good signal that you can then look at and you can diagnose. And obviously, we apply our AI, artificial intelligence algorithms to that sample in order to diagnose those things automatically. So Traditionally, that is kind of the physical limitation of applying vibration analysis, for instance, to being able to diagnose issues with slow rotating equipment. And we are solving for that, right? And we're obviously solving for that with a solution that utilizes ultrasound, a really high frequency sample, and also a solution that is able to take long samples from that machine, um, which is another difficult problem, especially for solutions that are wireless, because long samples really deteriorate battery life on sensors that are wireless. So here in this case, we're utilizing actually wired solution that enables us to get really high frequency with ultrasound and also really long sample times.
So explain to our audience when you say very slow rotating, we're looking at like up to 150 RPMs, is that right?
Very slow rotating for us is 1 RPM. Okay, and 1 RPM going to somewhere around 100 RPM. You can actually, without getting too technical, you can actually push the boundaries of what vibration signal can enable you to get, all the way down to maybe 100 or even 60 RPM. It just depends on the sensor type that you're using. But really, once you go below that, then you need a much higher frequency sample because you just will not detect the issues within the, let's say, vibration spectrum, which is, goes up to about 10 kilohertz, right? And what we're doing with ultrasound is going all the way up to 100 kilohertz, and that gives a much richer data set to diagnose those slow rotating equipment. So yeah, anywhere between 1 RPM and 100 and 150 RPM, this is what we consider very slow or ultra slow rotating equipment.
So what types of machine failures can be predicted?
There are really three types of issues or three types of faults that can generally be diagnosed, right? Usually it's some kind of lubrication issues. It's friction or rubbing, right? And sometimes kind of old school ultrasound vendors or providers can go and actually listen to the ultrasound and say, okay, I can, based on my intuition, right, as a human analyst, I can actually detect some kind of friction here in the bearing. And they can also start detecting bearing wear over a certain period of time. Um, we dramatically expand the capabilities of diagnosis. So we can start diagnosing things like unbalance and issues with motors, right? Slow rotating motors like rotor bars and gear friction and mechanical looseness and misalignment issues and motor sheaves. We can look at eccentricity issues. We can look at impacting. One of the issues we diagnosed recently for a customer was a large rotating cone, right? A very large, very hot piece of machinery that rotates very slowly. We were able to actually diagnose that one of the bricks that is in the inner lining of that machine fell and was moving and impacting the kind of the inside of that cone. That is a serious issue because that allows heat to start escaping, and it's kind of like a heat shield that's broken. Think about kind of the space shuttle. If you have a heat shield that's broken, it can actually um, severely damage the whole piece of equipment. Just with that find, that would have been impossible without the technology that we have. Or without continuous monitoring, we were able to save over 3,000 hours of downtime for that piece of equipment. So these issues that happen, and especially for such critical pieces of equipment, are incredibly severe, are just not diagnosable with traditional methods, or they are only if if you're lucky, right? And here, fully continuous, highly prescriptive monitoring can get them and diagnose them right away.
When you're dealing with AI, you really have to be careful about intellectual property of each individual company. So, how are you able to ensure that their IP stays secure?
Well, we have multiple systems in place and gates in place in order to be able to protect our customers' data. There's a variety of data that we take in. For instance, with the hardware that we have in sensing, that's primarily mechanical data. That type of data is typically not does not cause any kind of significant security risk for our customers. But we still have a kind of regulation in place internally, not to expose, customer information in any way, but rather, utilize it anonymously in order to be able to provide higher quality of diagnostics over time. That's for mechanical data. And when we talk about process data, which in some cases is really the heart of their manufacturing know-how, we have very robust systems in place in order to be able to protect and maintain it. And when we have access to it, we put a lot of effort in order to be able to comply and usually exceed the requirements of what our customers' IT teams have in order to be able to share that information with them. But again, that type of data is for the benefit of providing accurate insights and diagnostics for that customer themselves. And especially when we talk about process data, we have algorithms running that are specific to that instance and that customer. And so that is why, we are, I think we've seen a lot of success in getting through that initial threshold. And any kind of anxiety that customers may have about sharing the data is because we can clearly show that we have been complying or exceeding with the majority of the protocols that they have for data protection and security.